Let's talk about AI. There's this huge, nagging question right at the heart of it all. Can we actually trust it? I mean, as these systems get smarter and smarter, how do we really know their answers are right, or unbiased, or even based in reality? Today, we're going to dive into a new frontier that's trying to replace that blind trust with cold, hard, cryptographic proof. We're talking about verifiable AI.
Seriously, just think about it for a second. We're already leaning on AI for, well, pretty much everything, from a quick Google search to heavy-duty financial analysis. But what's really going on behind the curtain? When an AI spits out an answer, you just have to take its word for it. Let's break down why that's becoming a massive problem.
So, to really get why the solution is so cool, we have to get super clear on the problem itself. The way most of the big AI systems are built today, well, it has some pretty deep flaws when it comes to trust.
Right now, the AI world is dominated by these huge centralized models that operate like black boxes. We feed them a prompt and an answer comes out, but we have no idea how it got there. We can't see the process, which means we can't check their work or verify their performance claims. And that black box, it can easily hide some serious unintended biases. On top of all that, these systems are crazy expensive, they can be slow, and because they're all in one place, they're super vulnerable to things like censorship or just a single server going down.
Okay, so if centralization is the problem, what's the answer? Well, you go in the complete opposite direction. Decentralization. And this isn't some small adjustment, it's a total paradigm shift. We're talking about moving AI away from a handful of tech giants and spreading it out across a distributed global network. A really fascinating example of this whole idea in action is the Cyborg Network. At its core, it's a system that uses blockchain to manage a worldwide network of computers, all chipping in to run AI tasks. The whole point is to create a framework for AI where you don't have to trust anyone. And get this, the name itself basically tells you the whole story. Cyborg is an acronym for Cryptographically Yielded Blockchain Orchestrated Resource Grid. It's a mouthful, I know, but cryptographically yielded, that points to security and proof. Blockchain orchestrated, that's all about decentralized coordination. Every part of the name lays out a piece of the puzzle. So that's the big idea, but how does the rubber meet the road? How does this thing actually work? Well, let's walk through it. It all starts with a concept you may have heard of called edge computing. You know how with cloud computing, your data has to travel all the way to some massive centralized data center? Edge computing is the exact opposite. It brings the computation to wherever the data is being created, using a distributed network of smaller local devices. This slashes delays and just makes the whole system way more efficient. Okay, so here's how that all comes together in the Cyborg workflow. It's actually pretty elegant. First, a user sends out a request for an AI task. The blockchain then acts like an air traffic controller, assigning that job to participants on the network. They're often called miners. These miners use their own computer hardware to run the task. And now here's the crucial part. They don't just send back the answer. They also send back a cryptographic proof that they did the work correctly and didn't cut any corners. That little word proof is where the real magic happens. This is the piece of the puzzle that takes AI from something we have to blindly trust to something we can actually mathematically verify. It's a total game changer. This quote from the research just absolutely nails it. We shouldn't just trust the claims of AI model providers. And it's so true, right? These companies have huge financial incentives to maybe use a cheaper, less powerful model than the one they're advertising. And without a verification system, we'd have absolutely no way of knowing. The incredible technology that makes all of this possible is called zero-knowledge machine learning, or ZKML for short. It's a mind-bending field of cryptography that lets one person, or in this case an AI, prove to another that a statement is true without revealing any of the secret information behind it. It proves the how without giving away the what. Here is the absolute best way to think about it. Imagine a chef who claims to have a secret family recipe. Now, they're not going to show you the recipe card, right? Instead, they just cook you the dish. The incredible taste of that final meal is the proof that the secret recipe is real and amazing. But the secret itself, it stays safe. That is exactly what ZKML does for AI. And when you see it side by side, the difference is just night and day. On the left, you've got the old model, a black box. Something goes in, something comes out, and the process is a total mystery. But on the right with ZKML, the model gives you the result
and a verifiable tamper-proof certificate of correctness. The mystery is just gone, replaced by pure cryptographic certainty.
Okay, so this tech is obviously really cool, but what does it all mean for the future? Let's zoom out from the technical details for a second and look at the real-world impact of building AI on a foundation of verifiability.
Look, this isn't just some academic thought experiment. In really high-stakes fields, being able to verify AI isn't a nice-to-have. It's non-negotiable. Think about autonomous robots, mission-critical military systems, the financial models that run our economy, or even predictive models used in law enforcement. In any of these areas, we have to be able to guarantee that the AI is doing exactly what it's supposed to do, every single time, without exception.
To build that future, a network like Cyborg is designed around 5 core ideas. First is resilience. No single company or server can bring it down. Second, verifiability, using those ZKML proofs we've been talking about. Third is scalability, so it can grow to meet huge demand. Fourth, economic alignment, basically giving people a good reason to participate. And finally, state coherency, which is just a fancy way of saying everyone on the network agrees on the same version of the truth. Put them all together and you have the blueprint for truly trustless AI. And all of this leaves us with one final and I think really fascinating question to chew on. What becomes possible when AI is no longer a black box? When we can cryptographically prove every single calculation it makes, what new things can we build? What kind of world does that unlock when our most powerful tools finally become truly verifiably trustworthy?